All right, guys, so this is our last Flip the Classroom lesson of Chapter 2. In this lesson, we're going to talk about solving rational equations. And for us, rational equations are going to be equations that have terms with polynomials in the denominators. And so we're going to be looking for the x values or the variable values that will make those statements true. First, what we're going to look at is just an equation with some fractions in it, right? And we're going to talk about some strategies for this equation that we can apply to rational equations. So right here, one thing we could do with this guy is just to get common denominators and then combine everything into one fraction and combine all the like terms in the numerator and then basically just solve the equation in the numerator. But perhaps an easier method for solving this equation would be to multiply on both sides by the least common denominator, which is the smallest number that has both denominators as a factor. So right here we've got denominators of 4 and 8, and we would say that the least common denominator would be 8. Since right here, obviously, 8 is going to be a factor of 8, and 4 is going to be a factor of 8. So 8 is the smallest number that has 8 and 4 as factors. Now, when we multiply by that 8 on both sides, what we're going to see is our denominators canceling out. When I multiply by 8 on this side, I've got a multiplication of 8 and a division of 4. Those things cancel, and I get a multiplication of 2, which is going to give me 6 times x minus 5. And right here, what we're going to have when we distribute that 8 into both of our terms is 8x, and then when we multiply 8 and 8/3, we are going to get plus 3. Now right here, we can go ahead and solve this guy. This is going to be 6x minus 30 equals 8x plus 3. And continuing on here, we would get the x's on one side and the constants on the other, so minus 6x, minus 6x, minus 3, minus 3. And that's going to give us, right here, negative 33 equals 2x, divide by 2, divide by 2. And we can say that x is going to equal negative 33 over 2, or negative 16.5. Now, right here, we have 1 over x plus 4 equals 5 over 3x minus 2. This is a rational equation because right here we've got polynomials in the denominators. One easy way we could think about solving this guy, though, is just by cross multiplying, right? Since we've got two fractions that are equal to each other, one common method for solving for variables where we have two fractions equal to each other is just by multiplying by the denominators on both sides. So right here we would multiply 1 by 3x minus 2, and that would give us 3x minus 2. And then we would multiply 5 by x plus 4, and that would give us equals 5x plus 20. And again, right here we could just solve for x by bringing all the x terms to one side, so subtract 3x from both sides, and bringing the constants to the other. Oops, it's going to be 20. And then right here we would get negative 22 equals, and then 20x, divide by 2, divide by 2, and we can say that x is going to equal negative 11. Now, one thing we want to take note of right here, whoops, bring that guy back, move all this stuff over, is that right here, cross multiplying is really the act of multiplying by the denominator on both sides, right? So really what I'm doing is saying x plus 4, multiplying x plus 4 on both sides, right? And I'm taking for granted that when I multiply x plus 4 on this side, right, it's going to cancel out with the denominator. So I just get the multiplication of x plus 4 on the other side times my numerator, 5. And similarly, right here, we're saying that if we multiplied by 3x minus 2 on both sides, that right here, that 3x minus 2 that we're multiplying on this side is going to cancel with a 3x minus 2 in the denominator. And again, we just get the multiplication of 3x minus 2 times 1 in the numerator over here. So in general, we don't want to think of cross multiplying as just sort of coming out of nowhere. Really, it comes from multiplying the denominators on both sides. But since we basically are going to see those denominators cancel for both sides, then we can just sort of think about it as multiplying the numerator on one side by the denominator on the other for both sides. Okay, so let's talk about some other rational equations here. Solving for equations in one variable. So solving a rational equation, if f of x and g of x are polynomial functions with no common factors, then the real zeros of f of x are going to be the solutions of the equation And right here we would have f of x over g of x. And really what we're saying here is we've got one rational expression equal to 0, right? So basically the way we can think about this is a fraction is going to equal 0 when the numerator of that fraction equals 0. So right here, that means that this statement is going to equal 0 when we have 0 in the numerator, so long as we don't have a 0 in the denominator. And this is what we mean by no common factors. If right here, 5x minus 18 is a factor of the denominator, then we're also going to get 0 in the denominator and we'd be undefined. So right here, so long as the x value that gives us 0 in the numerator is not also giving us 0 in the denominator, we can take the numerator, 5x minus 18, and solve for the 0 right here. Just solve for x right here. That would be x equals, and then we would have 18 over 5. Solving by clearing the fractions. Here we've got a rational equation that's a little more like the kind of rational equations we're going to look at more in this section. This is, of course, an equation where we've got more than one rational term, right? More than one term with a polynomial in the denominator, right? And our strategy here is going to be to clear out the denominators by multiplying by the least common denominator on both sides. Now right here, for our rational equations, we're going to say that the least common denominator is going to be the polynomial, right, that has the smallest polynomial that has all polynomials as a factor. So in order to find my least common denominator here, the first thing I'm going to do is factor out all my denominators. So right here I'm going to have 5x and then over x times x minus 3. And then plus 2 over x equals 2. Now my least common denominator is going to be the smallest polynomial that has x and x times x minus 3 as factors, and that would be x times x minus 3. This has x as a factor, and it has, obviously, x minus 3 or x times x minus 3 as a factor. So right here, we can take these guys away, and we can go ahead and multiply by that least common denominator on both sides and get rid of the denominators for our rational equation. So right here we're going to say we've got 5x over x times x minus 3 plus 2 over x times our least common denominator of x times x minus 3. And then right here we've got 2 times, and then this is going to be x times x minus 3 on this side. Now right here, we're going to distribute our x times x minus 3 to both of our terms here, right? In this first term, we're going to see the multiplication of x times x minus 3 cancel out with the division of x times x minus 3, and we're just going to get our 5x for this multiplication into the first term. And now when we multiply into the second term, we're going to see the x's cancel because we are multiplying by x and dividing by x, so these guys are going to cancel. And we are going to get our 2 times the remaining linear factor, x minus 3. Right? Now on this side, we can just do our multiplication out. Right here, we can say we've got 2 and then x times x minus 3, which is basically what we're seeing there with our multiplication. Now right here, we can go ahead and simplify both sides. So right here, I can say I've got 5x plus 2x minus 6 equals 2x squared, and then minus 6x, right? Right here, what we can see is that we've got a quadratic equation, so we can bring all of our terms to one side and see if we can factor or use the quadratic formula. So right here, I'm going to combine these like terms first. We've got 7x minus 6 equals 2x squared minus 6x minus 7x plus 6, and right here, minus 7x plus 6. And this is going to give us 2x squared, and then right here, minus 13x, and then plus 6 equals 0. So right here, can I factor this guy? Yes, I can. I can say that this is going to be 2x and x, and minus, and then right here, I can say that this would be, let's see here, we have 6 and 1. These are our 2 linear factors that multiply to give us this quadratic, and then we can get the zeros of 1/2 and x equals 6. Now right here, what I'm going to need to do is check these answers, right? So immediately, we've got two answers, right? And we want to check them to sort of make sure we're doing our math correctly, but we also want to check them to we don't have any extraneous solutions, and we'll talk about that in a second. So right here, I'm going to check to see if these are actual solutions by plugging them into my original equation. So right here, I'm going to have 5 times 1/2 over, I can say 1/2 times 1/2 minus 3. I'm going to plug it into this form with the factored denominator. I think it's going to be a little bit easier to deal with the denominator there rather than squaring that fraction. And then plus 2 over 1/2 equals 2. So now right here I've got 5/2 over, and then this is going to be 1/2 times, this looks like it's going to be, that's going to be 3, which is going to be 6/2, so that's going to be minus 5/2, so this is going to be negative 5/4 when we multiply those guys. And then plus, and then this guy I can multiply by the reciprocal with and get 4 equals 2. Now right here I can multiply by the reciprocal of that negative 5/4 and get right here 5/2 times my negative 4/5 now, plus 4 equals 2. And these guys, the 5s are going to cancel when we multiply those two fractions, and we are going to get negative 4 over 2 plus 4 equals 2, which is going to give us negative 2 plus 4 equals 2. And that's true, so we know that x equals 1/2 is going to be an actual solution for us. Now right here we can do the same thing with our 6. So right here, plugging this in, we can say we've got 5 times 6 over, and then this would be 6 times 6 minus 3, and then plus 2 over 6 gives us 2. So this is going to be 30 over, and then right here we can say 6 minus 3 is going to be 3, times 6 would give us 18. Oops, 18 is a little weird there, that's okay. And then right here we've got 1/3 equals 2. Now I can reduce that to 5/3 plus 1/3, which would equal 6/3, which does equal 2. So this is actually a solution as well, right? Now, obviously I want to check this just to make sure I did my math right. That's always a good idea to check your answers for that reason. But also, when we multiply by a least common denominator on both sides, there's the potential of what we would call an extraneous solution, or an x value that would not make the statement true. So that's also something we're going to need to watch out for when we're using this method of multiplying the least common denominator on both sides to clear out our fractions or our polynomials in the denominator. So right here, what I want you guys to do is to go ahead and give this one a shot. You can pause the video right now, and we will look at this together in a second.